Am I not streaming? Okay, maybe I'm there. I might be streaming now. Still trying to figure this out. Yeah, I was there. There was a new thing today that I was checking out. Oh, okay. It seems like I'm streaming now. That's like, it's for backing data up to S3 using. It does like a distributed thing where it's supposed to make sure your data persists like forever. Basically, once you push it up to S3, and it will automatically back itself up, and it's using the script I saw was in Python. Yeah. What was it called? It was, yeah, Camless Store. They don't really have a front end. But yeah, basically, like I said, your data should be alive in 80 years. Yeah, which we might be. They're working on that. Yeah, right. Right, exactly. Well, something like S3 is like 0.012 cents a gig or something like that. I mean, you could. It would be like $1 a month to back up, I think, all my data pretty much. I need to figure out a way to store it better. Oh, interesting. Oh, nice. Yeah, I get random charges from Amazon that I'm not even sure. I think I had an EC2 instance that I wasn't using. That I forgot to spin down, and they've been charging me for like a year. I finally figured out how to turn it off, though, I think. Is Alexa here? Hey, Alexa. Oh, and Aaron. What's up, guys? I'm just reading over the rest of this chapter, no big deal. Yeah. I know. Definitely a breather. There are a couple cool things, though, I learned. Especially about the unwinding the stack, and how, like, kind of how error propagate. I don't totally get it, like what's going on the language level as far as how it's tracking like the call stack and everything. I don't know. I think that's something they're kind of working on as far as like supporting proper tail calls. That's supposed to get a little better, but I don't know. Yeah. Yeah, luckily it'll kind of stop itself. I, I, I kind of think there's some kind of detection where it knows, like it can tell if your function is like in a tailspin, and rather than eating up all the memory, it'll throw that warning. Yeah. Oh, you know what? Yeah. Mm-hmm. Yeah, it's interesting how there's kind of. So does the do we know? We never really talked about this directly. I don't think is as far as because it's something I've only recently known about. The stages like as the I guess as the JIT compiler is happening. How there's you have like the compilation stage where it's taking all your variables and anything that's like an object, it puts on a hash and hoists everything, creates all those spaces in memory that basically are either values or pointers to values. And then the stack is the actual, basically just a synchronous list of functions that will then use those whatever. Is it creating ASTs at that point, or is that just a way of representing like function scope? Does that make sense? Like an abstract syntax tree. So that's how that's how you're able to transpile stuff. So it's kind of like a language agnostic representation of your data. It's how like Babel works. So you can write something like in one language, and then it's basically able to represent that in memory, give it a name, and run it on a lower level. So you could even transpile it, like you could represent the same syntax tree in any language. So it could be, you could go from JavaScript to Python to C. But I'm just wondering. I guess that's one thing I don't know about is like, are there? Mhm. Yeah. Yeah. Yeah, that's interesting. So is it? So whenever those representations get made, are they? Is it happening? I guess I'm unclear about if the program is looking at your entire, or if the interpreter is looking at your entire program, or if it's just going through and making these like nested contexts. Yeah. Right. Yeah. Before it's that. Yeah. That's right. Yeah. 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 What's that one? Somebody actually made a program, and this would be good to look at. Um, There was this guy who did a talk called, I think, like what the heck is a call stack anyway, or something like that. Uh, yeah, this should illustrate that, I think, or at least it was meant to. Let's see, what is a call stack? Weird YouTube stuff. Just don't worry about any of that. Uh, Right. Oh no, the event loop. That's what it is. I mean, still, there. Yeah, this is it. Okay, this guy, Philip Roberts. I think this is it. Yeah. Yeah, I'm looking for this thing that he made. It's like a little web app that kind of illustrates this. Oh, here it is, Loop. That's what it is. Visualization to help you understand JavaScript's call stack / event loop callback queue. Interact with each other. The best thing to do is to understand how this works is watch this video, and when you're ready, go. I'll have to watch that video later. So basically, we run. I think it's gonna actually generate like a syntax tree. I think. And then we can change it to see what happens. Create an HTML elements in the gray box at the bottom left by hitting the edit button. Listen to the DOM events on the button. Click. Hit the tool icon at the top left to open the menu with extra settings. It's called Loop. Yeah, latentflip.com/loop, LOUPE. So it is running through Esprima, and Esprima is that thing that will generate the AST, which can then convert it to anything else that runs on the LLVM, the low-level virtual machine, which is what's doing. That's why like we never mess with pointers or anything in JavaScript. It's all abstracted away, and the runtime's actually doing that along with all the garbage collection. Which is why, like, sometimes JavaScript developers don't really know what's going on because we don't have to mess with that stuff. Yeah, no hex. Yeah, exactly. That you can name anything. So there's some instrumentation going on under the hood, basically. Adds a bunch of while loops everywhere to slow down the code as it runs. This modified code is then turned back into JavaScript and sent to a web worker, which is basically a background process. As it runs, the instrumentation sends messages to the visualization about what is going on, so it can animate things at the right time. It also has some extra magic to make DOM events and timers work properly. Alright, let's see if we can do anything with this. It's a latentflip.com/loop, or you can just probably type in loop. Am I not screen sharing? Oh, okay, so I'm screen sharing YouTube. This is part of the thing. So Google Hangouts on Air doesn't exist anymore. Now it's YouTube Live. And so like what I'm trying to do is, like, this is what the live stream is, which hopefully it records. I don't even know if it will, but we're streaming live right now, and so people could be watching. No one is watching. Someone could be, and then I think once I stop it, it'll make that recording available, because that's what Hangouts on Air was doing. It was like live streaming, and then it would record and post it to YouTube for you. But they disabled that for some reason. So I'll just, since y'all are on Hangouts, I'll just share my screen. And I'll try to figure out a better method in the future. Let's see. I guess YouTube. Can y'all see this? Okay, so okay. Hide your little faces. Sorry. Okay, so this down. So we have like a jQuery function that's adding a button click event with this is just a named function that sets a timeout that tells you you click the button after 2 seconds. And it's probably important that these things are named, so these aren't anonymous functions, anonymous function expressions. They're actually named. So yeah, and so this is what's generated here. This is the click me button. And save and run. Now it's actually going through what's happening. So here's our timeout. I didn't mean to do it right then, but okay. Let me pause. Oh, okay. So here's our DOM here. It's just the HTML button. And I can click. Nothing happens because it's not running. So I went through the onClick, it did the console log, said hi, started the timer. This is going on in the background process, and then I have a callback queue that gets made, and then it goes back onto the call stack. So it's mostly, the main thing is about this callback actually goes onto another queue, which is separate from the event loop. And it's actually running on a different thread, which is how asynchrony is able to happen. And why callbacks are asynchronous in nature. Because they're actually, the browser makes a different stack. And that all happens really fast. So if I do, I just throw a new error. So this is gonna happen after. Oh, and I need to bring up my log. There's like almost too many things on the window. So, okay, so I'm gonna clear this. And now we're also getting an error. So right. Oh, did I lose you guys? Oh, okay. Okay, I'm gonna click the button. You guys ready? And then that finally resolves last. So this is the last timer. Because I never click the button, and I don't know why it's not actually on button. Maybe I need to give this an ID. Split. Cannot read property split a bunch of times. Yeah. Maybe I'll give this an ID. Oops. But unclick. Does that look right? I might need to save. And I can actually pause right here too. Okay, so there's my butt. $sign is not a function. So dollar might just be the window. Yeah. Command line IP. Does jQuery exist? No. Okay. Wonder if this will work. Does that look okay? On click. Let's see what happens. Document is not defined. Okay, so it's probably the dollar sign is probably a special variable. I'm not sure how he has it set up. Yeah. Yeah. It's always good. So maybe I'll do. See what happens then. Hi. There's nothing on the call stack right now too. Okay, so then timeout. It did say click the button. Yeah. Yeah. Oh, you can. Interesting. Yeah, always the best. And this is just failing over and over. It's ridiculous. 6:31. Oh, it's the timer. Okay. Let's rerun. Wow. All right. Cool. Turn that off. Yeah, so there's some. Yeah, I'll have to mess with this more. I can try throwing an error and I mean, it's probably just going to be anonymous at that point because it's not a real error. Alright. Yeah, he's not defined. So normally, like, if an error is generated, it's the response that gets passed to this constructor. Oops, I did it wrong. Yeah, this is probably not a great example because it's not working properly, or I'm not doing it right. I was just kind of trying to show the like different stacks. That was the main illustration, I guess. I wanted to be able to see like call stacks and oh yeah. Sue. Yeah. Just have like oh yeah. let's see, this is probably ES5. Okay. Sweet, yeah. See you at Note School. Take it easy. See what happens here. Oh, yeah. Right. So, let me do this. So I'm just going to log these two numbers. Huh. Named function is not a function. I got a type error. Well, I think I'm just making it an anonymous function. This will get called when I return it. I think this should work. I'm gonna switch over to a slide. Yeah. Okay. I think I just said the opposite of that, but I think you're right. Let me try this real fast. JS Fiddle has a little better, I think, error handling and stuff. Just want to try running this real fast. Do I need to show the output? Yeah, it's not logging. Okay. This isn't getting called. I think it's this method. I did something wrong. That shouldn't need it. Shouldn't. Oh, yeah, it's just returning the internal method. So it's just returning the definition of that internal method rather than running rather than the console log. Interesting. Oh, okay. Ah. Friends. Yep, there it goes. Yeah. Cool, thanks. Huh, it still says named function is not a function. So there's a call stack. Yeah. It would be nice to see a hash over on the side that has these values where it's taking these and putting them in memory. It puts it on the stack. Oh. Is it loop? Cool. Yes. So there's no it works this time. Yeah, and it outputted 21. Okay. I think I can turn up the delay. Internal method, and then it does the console log, and then yeah, because console log is actually a remote call. Turn that on. Yeah. Yeah. I never actually seen that. Right. Wow, look, it actually... Yeah. And since it didn't, it kept those on the call stack. Yeah. Yeah. So I think what I can actually do is right. Right. And I just throw, right? Throw E. Okay. Oh, because I'm already throwing that. Oh, okay. So I just want to catch it and log. Okay. Yeah, it said I'm in error. Yeah, just log. Yeah. Right. No, it finished unwinding. Because it hit that catch. So that's good. That means your program will keep executing. Yeah. Like really useful. Yeah. So if I log stack here instead of message, I wonder if it'll show line 9 where the error was thrown from. Okay, so first we did name function, so that got tried, and then it called that internal. It's called console. And now it should hit the error. Yeah, and there's the eStack. Error, I'm an error. Oh, and it did the message as well. So that's the error getting thrown, and then that's it getting caught, and the stack trace. Which are these like React IDs? Oh, it's in a blob. Cool. Internal method, named function, blob. Yeah, that's the stack trace. And it's still... Oh, when I clicked off of it, it went back, but... Oh, it looked like those were still on the stack after it ran through. Yeah, we can see. Or, yeah, if it puts it on top of them. Or... after the error. Yeah. Mm-hmm. Yeah, I wonder why. Yeah. Yeah, I got that. It did log. This ran, and it after that. Like there. Finally, blocks can be Make sure your code is always run when the block finishes. Yeah, which could just be the app itself. But so I wouldn't put finally here. I've never written a finally. What? I think so. Yeah. I didn't get that far. Yeah. Oh, so it's content in this case is it is a getter, so it's just a way of specifying like this is a method that returns a value versus set. Like we could have set content, and they could have the same names, but they're actually two different methods. And this. I think you would do box dot. How do you call a getter? Right. Depending on what you're doing. So we can get a better example. Like a get and set. These are just getters. Oh wow, this like really changed between ES6 and ES5, where they must have 0 parameters, but in ES5 they had to have 1 parameters. Delete. Mm-hmm. It should call that, and since it's true, it should throw this error. And then just return an empty array. Yeah, locked. Called from then. Oh, it probably doesn't even get to this return. Yeah, just the empty array. Because that's what's being returned. Yeah, and I think if this was set, yeah, it wouldn't work. Setters must have exactly 1 formal parameter. Because we're not setting anything, so it makes sense that you would have to pass some kind of new value to a setter function. So if I did that, and that's one way of differentiating, I think, between gets and sets. Because if I have set content, even though it's kind of like pseudo property, like you were saying, I could have return like this downloads. Yeah, I'm not doing this right. I shouldn't return anything. Well, nothing's going to get returned. Never mind. I don't know what I'm doing. How do I can we write an internal method that's just change? Oh, there's already lock and unlock. Never mind. It's unlocked. Takes a function value as an argument, unlocks the box, runs the function, and then ensures that the box is locked again for returning, regardless of whether the argument function. Okay, so we know we're going to use a finally there. Only or through an exception. Cold piece. So, and we don't change this box function at all, right? So we can try to insert to do the thing. Try body, and then if it fails, we'll just, I guess we'll throw E for now, and then finally, and then ensure, and then we know, like, finally for sure we're going to call box.lock no matter what to make sure that it's locked. So in our catch, we can go ahead and do the change, so we can call box.unlock and then body, whatever that does, and then I guess just console log the error if it catches one. Is that what y'all came up with? Something like that? Well, error raised. Looks like I got. Yeah, so I think, but this catch will also do that, right? Because if we hit this error, then we're never going to get this. call box. Box is unlocked. Box stays unlocked. That's just another if statement. Is this the right thing? I mean, so I'm getting locked, and then error race, and then true. Yeah, I was just logging. Oh yeah, that's a good idea. Box dot is just box dot contents. It's just the array, right? Oh, underscore content. Oh, right. Content. So it's just box.content. Okay, and then I'll log this message too. And I'll break these up a little bit so they're a little more readable. I don't know if that helps. Might not. Okay, so it's got 4 gold pieces. That's weird. Okay. So which is what? Which is just lock in this case, right? Is there additional cleanup? Oh, okay, so I shouldn't run it that. Okay. So really, I probably have too much gold in there because I've been running the body in either case. Okay. Yeah. So I actually want to like delete box dot. Oh, that could be a set thing. Could we write a set function that would do that? Set like box content. Is this how setter functions work? And just do content equals. I might have to do this dot content, and then just call box content. It might ask for a parameter, which I just make X and pass in an empty array if that's the case. Box content is not a function. Yeah. Looks like one to me too. Set prop val. Set expression val. And we're naming a property. So it's like the setter is an anonymous function that we bind to that property. Setter can be used to execute a function. See an example. Set current string. Yeah? Okay. Oh, I need a comma. I just needed a comma. Oh, really? Oh, yeah. Blocked. Well, I just want to pass it an empty array. Do I need to return? Should. It's not return. Well, it should still work. Oh. Yeah. And because I'm running this after. So let's go ahead and so in the finally block, should I log the contents? Or run that getter, I mean. So that should get the content. Yeah, which is just an empty array. Which makes sense because it's locking, so this body is never getting called. So if I run it here. For some reason this this finally seems to be getting called twice. Oh, wait, no? Box that locked. Sure. Oh. Huh, should I not? I didn't even look at this part. So I'm just gonna try to call my function. And then it has a callback that just calls an error. So this should get called. So a throw will get called only if there's an error? this student unlocked? Oh, because we didn't unlock. That's got to come after the unlock. Yeah. I think that's the behavior. Yeah. Locked, gold piece. And if I do it again, it should be 2 gold pieces. Yep. So, the bad thing about this, you cannot read this code and understand what's going on. So, even though it solves the problem, I would not pass this, I think, for a code review. But it's what I wrote in a mere 20 minutes. I think I would do more of a just have like a ternary that was just checking the lock status, because at least you kind of have a. I mean, maybe control flow. I mean, maybe this try catch. Right. Yeah, and you're not going to know. It'll just silently fail. It's really good. Mm-hmm. Yeah. So that thing I just said was totally wrong. Oops. Just about so this actually has a ton of benefits, writing in this style. And I guess I could just use comments to describe what's going on. Yeah. I wonder what the okay. Hey guys. Yeah. Okay. Right. Okay. Since you don't have a catch after the try. So, yeah. Yeah, that seems to be kind of earlier in the chapter. What he was saying was like the error kind of races up the stack. Yeah. Yeah. Well, that's whether there's an error or not, right? I was gonna take a look at the solutions, and just see what if we're if there's anything we were missing. That looks good though to me. The more I look at it, the more I'm starting to get it. Yeah. Oh yeah, Jay. And there's. I'll share my screen. They don't have a catch block. So, yeah, it looks very similar to yours. I think you just had a function that would check if it was locked. So it just sets it to a variable. Because you already know it's not locked, so you can execute the function that was passed in and then return. You can jump out. You don't need to do all this other stuff. But this finally. Oh yeah. Yeah, this is usually I see this a lot, and I don't know all the reasoning behind it, but usually it's if statements have nots because it's already kind of truth, like everything's sort of truthy anyway. So you can usually avoid one side of the logic if you just check for knots typically. And so even in this, even though we're returning the body, this finally is still going to execute. So like is that what's happening? This function is getting a finally method that just always gets called. Oh yeah. The box stays unlocked. Oh, okay. Oh, okay, okay. So this never gets that doesn't get called. Yeah. It seems like no, it would only be once you've entered the try. I think. Okay. So that's consistent then, I think. That's what we would hope. That would be weird if you had something that would get just called every time you called a function. A stowaway. Yeah. Okay. Cool. Do we want to look at that other one real quick? I didn't even check it out. Retry. So you have a function with primitive multiply that in 50% of cases multiplies two numbers, and in the other 50% raises an exception of type multiplication unit factor. Write a function that wraps this clunky function and just keeps trying until a call succeeds, after which it returns the result. Okay. Make sure you handle only exceptions you're trying to handle. So can we do like type of error to check for that? And random. We just call itself first, right? Cool. Oh, is it instance? You might instance of. Okay, so this is a property on the E. Oh, so just like typo, basically. Yeah, I'm trying to make this recursive where it just calls itself. I don't know if y'all can see. Can I check it like this, or does the type need to be in quotes? Ah, okay. Oh, I just... Oh, because it's actually a type. Oh, right. Yeah. But if there... Oh, what was our exception here? If it is of that type? Oh. Well, this just makes sure that it gets called. But we actually want it to call itself. Yeah. Well, yeah. If I get an error. In the finally, but the finally only gets called if it has a if it gets an error. Did we figure that out earlier? Okay. Oh, right. Okay. Okay. Yeah. It's just gonna. Oh yeah. And it finally returned. Yeah. We just want it to call itself finally. And then break right here, you're saying? That's just going to return itself every time. I just want to return a result. Yeah. Yeah, and this should never get called anyway. Because there's only one E. Yeah. Yeah. Which will bubble all the way up. Yeah, I think so. Illegal break statement. Yeah. Undefined, undefined. Okay. This might be that. Yeah. So it did call itself 4 times. Yeah. 64. That time. And then it did 5 undefined. 0 undefined. Can I return result if it's here? Result is not. Yeah. Good. I love taking stuff away. Oh. So what happens then? Is this our else? No. This should never get thrown, I don't think. No. So our results. Right. Because that try never gets called. It just like skips back to the catch. Oh, it's because it's logging this. I think this is the undefined thing. Hi. I yeah. I wonder what happens if I just have it recursive, because it's basically, if this result doesn't get returned, I want to call it again. Yeah. See, like here it eventually. Right. This is it. So this gets called like 100 times, but then it eventually gets 64. So yeah, that's how I wanted. That's how I was thinking. And I could even. And so instead of returning here, even we could have that in a finally. So see how I removed it from the if, I'm just logging, and I just want that finally to fire every time. So this will accomplish the same thing. Woo! Oh, nope, maximum call stack. So, oh, that's because it's calling finally every time, so it's just calling itself over and over. Never mind. I can't use finally like that. But I can still just return that. And yeah, I get 64, undefined, 64. Cool. And I'm not doing it again in the catch, because that's probably bad practice. Because I really didn't want to fail. What do you mean? Great. Yeah, so it's. Yeah. Have you heard of that? That's one of the types of like QA. They call it like drunken monkey or something, where like you have this whole system, and at randomly QA will just bring down parts of it and see how you react to it. And they call it, it's like a drunken monkey, like pushing things over. Something on fire, which turns out is like a really good way to do QA actually, because it's more about then like how your devs adapt to failure. I mean system failure. Okay, let's see what they did. 4-0. Alright. So this just returned. Oh, I like mine better. This one doesn't do all the undefineds though. It just always throws. Because it's actually throwing in. If not, so that'll never happen. What? This is confusing. So because it's an error, it's going to do the 4 again? I didn't know about that. Yeah. Hmm. Hmm. It's really interesting. Yeah, I really had no idea about this too. For semicolon semicolon. Yeah, or yeah, I think you have to do while. But for sure that one, where the condition comes afterwards. Yeah, or it'll just like run forever. Yeah, just while condition statement. Yeah, it's a little playing with fire a little bit. So, I just wanted to try. I'll do my not as my unreliable reliable multiply, and I was just gonna stick it in here and see if anything happens. So it calls reliable multiply and then reliable multiply. Executes primitive multiply. AB the math.random. Okay, I saw the instance of, and then we got multiplicator. Oh, interesting. Did uncaught exception at reliable multiply. Might be because this isn't. I'm not throwing an error. I'm throwing a function. But that's. So it's not an error. Well, I wonder if I could do new. If I could just wrap it in an error. Oh, okay. Rather than. So what? Can the error primitive take a function as its argument? Like if this just console logs? Why not? Multiplication. Oh yeah, it called. Huh, that worked. It did high. And then it called reliable multiply again. Yeah. It did the random. Did random. Did failed again. So we should get another high. There it is. And then we'll call reliable again. Failed again. I think I can actually speed this up. It's It's just not doing math.random less than. Let's do less than 1. That should for sure run. What? It must not have a valid math object. I'm just gonna do 0. Because this isn't a real... Okay, then it called A times B. Okay, and then it took those off the stack and returned null. Weird. Alright. Yeah. I think I'm gonna look into this more. I'm probably doing something wrong. Or I just don't know its capabilities. Or something. Anyway, yeah, that was fun. That was cool. No, it just keeps returning. This try is never getting called, looks like. So it's almost like it's trying to do this before this function's defined. I don't get it. It's not returning. It's not returning this. Okay. Oh, maybe it doesn't like, I bet it doesn't like this syntax, maybe. Still return null. I don't know. I don't feel like debugging it anymore. Yeah. I'll figure it out. Do better next time. Let's see. What are we reading for next week? I'm gonna reread. Oh, nice. Okay, cool. I'll show y'all the 2 sites I use for most of this. This one's a really good just work through for they go through pretty much all the flags and conditions and stuff, and they give you, so you would like write your pattern here and you try to match all of them. If you can't figure it out, you show the solution. And you can go on to the next one. I've already done all these, but I need to do them a lot. And then this one. Yeah. Yeah. You almost kind of have to force yourself to use them to keep up on it. Yeah. Right. This will actually show the flags too. So, like if you want to use, oh, did it bring something? Oh, cool. Anchored pattern is forced to the caret. So this site's awesome. It shows all your logic and how it's nested, and then whatever you match it to, how many steps it takes, and what is? Oh, there we go. Right. Yeah, so you can do JavaScript. That's cool. Yeah, so those are my two favorite regex things. Regex1.com. That's a really nice one. And then there's even another one Leah Veru had made, Regex Playground. It's kind of similar, just the font's a lot bigger. So you put in a string here, like Vietnam, and then you can match, or say I wanted to match something with like 2 letters, like yeah. Huh, I thought that would work. I don't know why that didn't work. Anyway. I'm not good at this. Yeah, I'll post those 3. Yeah, really high intensity validation and practice. Cool, yeah. I'll just post these. So there's Regex Explained, and then Regex 1, and then Regex 101. That was 3. And then it was Loop. It's actually this. There's that URL if y'all want to mess with this at all. Good luck. Cool. Yeah, well, I'm gonna go to sleep. It's my bedtime. Yeah. This was fun, y'all. Let's do it again. Yeah, like a hash. Yeah, that's what I was hoping. I don't know how you would have access to that, because that's the interpreter. Yeah. There's gotta be a way, though. Mm-hmm. I mean, that... Yeah. And it's doing that, I mean, that shouldn't be too hard to do, because it's using this as Esprima as the, that's the parser. So it's like calling out to, here we go, here's an AST. So we just have this answer, var answer 6 times 12, type body, variable declaration, variable declarator, type identifier, and the name answer. Oh, my bad. So this is the parser Esprima, and I just went to demos. I think I was in syntax validator. Oh no. Oh yeah, this is how it's doing syntax validation too. Yeah, that would make sense. I mean, this is basically a parser and AST builder. So here's the tree, and then all the tokens. So you can actually do something where you're, like with Bison. Is that the Lexer? There's a JavaScript one, Jison. It's this, yeah. Your friendly JavaScript parser generator. And it's pretty cool, so you can actually parse out a string and then convert those into objects to do things with. So like autocompletes and stuff like that. So that's what this is doing. They made a little calculator that takes characters and then operates on them according to this lexer. Yeah. You'll need to. Oh, and it's available as an npm package. Yeah. Totally. And then Esprima was that other thing. Function instrumentation. I'd really like to be able to see the hashing and how the scopes, like if there was nesting of scopes and how that was happening. I think that would be the perfect visualization for closure, or for closures, because that's tied into this. Oh, cool. Yeah, so here's we can also take all these tokens and change them. So this is like indent with 2 spaces and use double quotes, single quotes, use tabs. Because every one of these characters, including the empty spaces, are actually tokens to the parser, and that's oh yeah. I mean, this is what like Babel uses this. Esprima can be used to perform lexical analysis, tokenization, or syntactic analysis, parsing. It should be. Yeah. I think that's in the type too. I think that's part of what is yeah, like this declarations, that's a hash. Like if I make more variables, Um, yeah, it actually. So it's all contained within this body, and this is one. This is the first var, which has this kind of information about it. Binary expression, what the operator was, and then the values left and right. And then this is a string, so it's a little simpler since it's literal. It was called with var, so I can do let as well, which would have different rules. So this is the parsing. So this is what actually goes in and gets executed, not this. Yeah, and then and there's all our tokens. Yeah, this tree is kind of like what I was wanting. I didn't know this was here. Cool. Oh, and you can attach comments to them. Nice. Leading comment. And the trailing comments. Range. Oh, so that's how you get like a range, because that's actually the index of the yeah. 92 to 105, which are actually just the tokens. That's the index of the token that it exists on, I guess. There's probably that many characters actually in this whole program. And you can save the URL. That's cool. So you can just paste this. I should generate. Yep, the same thing. Index-based range. Yeah, this is like beast mode. Module loading. Yeah. Yeah. Super internet. Alright. Oh, that's me with short hair. Alright. Bye, guys. That was fun. Good night. Y'all take care. Bye.